Trojan Source Code. So some of you may already heard about that because it's kind of it's happened already like quite a while now because the paper was published last year. But it generally just talk about like how there's something that we could exploit in the source code. But well, first of all, like I have to put some helmet on so like people don't ask me questions that's outside of what I kind of understand because I'm mainly talking about like in Python's perspective. If you ask me about like, oh, what about C? Then I'll be like, I don't know. So yeah, just saying. Also, there's my contact details. So if you want to find me on Twitter, you're very welcome to, or GitHub. Well, I don't have much on GitHub. Well, I do contribute to open source, but it's a big mess on GitHub. So yeah, don't expect many amazing things. Before I dive into what I'm going to talk about, I just want all of you to help me look at this code, maybe debug it a little bit for me. Well, maybe it's completely fine, there's no bug in it. Like, who think this is completely okay? Whether Python, everybody knows about it, is, happening in the textbook, or who think this is completely fine? All of you think that I'm tricking you, right? So, okay, fine, that's fine. I'm showing you that I'm not tricking you. Let me see what I can do. Okay, because this is not my computer, so it's going to be a little bit funny. Oh, I found my mouse. Okay, cool. So what I'm going to do is I do have this interpreter that's already loaded somewhere here. So I'll just, I don't want to log in, I just want to code for free. Thank you. Right. So yeah, I should have loaded this one, isn't it? Okay. So it's just the interpreter online. I just found it. It's free to use. It's nice. So everybody loves Hello World. So let's do our Hello World. So, oh, I've copied it. Why is it not pasting? Is it Control V doesn't work on Windows? Paste. Why allow? Paste. Why can't paste? 1 second. I need to copy paste. Come on. Control C. Okay. I'm so dumb. I can't even control. Okay, Control C, Control V. Okay, this is perfect. Like Hello World. So let's run it, right? So, enter to run it. Okay, fine. Let's run. Yay. Hello world, nothing. It's good. We are good. We are a complete beginner, even though I can't copy and paste. But yeah, we have successfully written our first Python language, Python program. Yay! But I told you it's going to be a trick question, right? So what about this? Right? So this is someone else written this code. Is anything wrong with it? And then now you also think that, oh, there's a trick in it, isn't it? Okay, so let's hope the copy and paste work this time. Okay, I paste it because the enter does not appear. So let's run this code. And an error! Oh my god, what have I done? Is it because of all these like trailing enters? It should not matter, but I mean, yeah. What happened? I'm so scared. Oh, why? Well, because there's something that doesn't meet the eye. It's happening here in this code. It is very tricky. I guess I tell you, it's the trick thing. So these two codes, right? Let's go back to the slides. These two codes look exactly the same, look exactly normal, but they don't run the same. One is completely fine, just like what you expected. The other one, there's a trick in it. So what is this trick? So before I jump into it, self-introduction, I'm Cheuk. I love open source. I now work with Terminus DB. I have some sticker with me. If you like that cow thingy there, then come talk to me. I'll give you a sticker. Also, I organize a lot of events. I'll talk about one of them at the end. Yeah, I also stream on Twitch, but let's not dive into it. So Unicode is very weird, right? This is like the most famous name that I really love because, like, obviously someone want to print something about Unicode. It's either a heart emoji or maybe a poop emoji. I don't know. But this doesn't render, so it's kind of like it could be both. You don't know. I don't know. So Unicode is very weird. Like, it's not all system, everything except the Unicode. So. Yeah, and also the fun fact about like that is Python. We all love we can write Unicode in it. So I think a lot of people already make fun of it in lightning talks. I remember James Powell, another keynote speaker. He also talked about a lightning talk in PyData about writing in other languages in Python and stuff. And this is my friend Mark. He is a Python maintainer, a pandas maintainer, and then he have this import pandas as panda emoji in one of his lightning talk. some time in the past. So yeah, you can use emoji in Python. Yay, we all love it, right? But it's not just fun, because there's another lightning talk idea that I think about, but I've never really executed. Is that, oh, what about if I put a Unicode no space, zero width white space in the code and we execute it? Well, because you create some error. Exactly like what I did before in a trick question, because Unicode is weird. So why is Unicode so weird? Why we can't have normal just characters and symbols and alphabets? Like why Unicode? Sometimes there's some Unicode stuff that is actually you can't see it. Why is it invisible? Because they are functional. They are functional Unicode characters that help to interpret other characters. For example, we have lots of different writing systems in the world. Some of them is not always render from left to right. For example, I grew up in Hong Kong, so my mother tongue is kind of like Chinese, Cantonese. So Chinese also, sometimes we don't always write from left to right. In Asian time, people write from right to left. Also happen to other writing systems. For example, Arabic also from right to left to right, right to left. The other also like Hebrew also from right to left. So Unicode tried to solve the problem of not just being big. Unicode try to be inclusive, right? Include all the writing systems. So we need this functional character to handle this kind of stuff. Also, Unicode is quite old. It's kind of older than you think it is. I remember, so the most popular one that now we see everywhere is UTF-8, which just means that like each character is using 8 bytes to decode it. But I remember there's also something UTF-16 or something, and especially when you're like me, grow up in Hong Kong, and then all the information you get is written in Chinese, and then there are some websites that are written in Chinese, but at the old times, I think also Netscape time kind of old. So the encoding is not always, it's not standard to have the encoding written in the HTML yet. So the default is just ASCII or something like that. And all the Chinese website will become like crazy, symbols that you don't understand. You have to manually change the encoding to Unicode to make it work. Yeah. Also, the emoji looks different on Windows. I didn't know that because I'm used to the Mac, on my phone when I do WhatsApp and stuff. So yeah, so this is an emoji that we all know and love. You send a lot when you message a friend and your family. So this actually was added in 2014. So the Japanese kind of invented it. They, because like maybe if you kind of like dive into it and like me, being curious about everything. So Japanese, they always like to express the emotions with the text. So they use, at the beginning when they text someone, text a friend, they will use the ASCII character to create kind of a face. We all know the colon and the what's that? Parentheses. Yeah, it's a smiley face, right? And Japanese got a lot of them. And then one day, maybe someone would be like, oh, how about we just make a Unicode character that is the picture, right? that's emoji. That's how emoji is invented. But that was long before that. There's people already trying to express themselves using different symbols. So let's come to this troublesome. Is troublesome in some way if you use it in maliciously. That is this bidirectional kind of characters. So, like I said before, some writing system is not from left to right, it's right to left. So you have to have a way to tell the computer that, okay, this time I'm writing, let's say in Arabic, I have to read it from the other direction. So you have to put in the functional character, which is not visible for human eyes there, but when the computer sees it, it's like, now I have to go the other way around. So when I display the context, I have to write it from right to left. So in Unicode, we have this special character. We call it a bidirectional character that is telling the system when they display the text, like which direction it's going. So it creates a problem when you use it in code because, well, as we all know, when we code in Python, it's mainly kind of similar to English, right? So it's like from left to right. So when you use that, but also because Python accepts Unicode. So when you use that bidirectional character, that would be some crazy things happen. Because when you see the text that you have, right, it looks very normal, just like your normal Python code. But actually, when the computer read it, if there's a character that's added there, it's like, oh, right to left, then it would just suddenly, go to the end of the sentence and go from there. And it's different. The way the computer read the code is different from how you see the code. So so that's why it's called Trojan Source malware, Trojan Source Code, as the paper mentioned. So Trojan horse. Actually, the last time I gave the talk, I didn't really look into the history of all this. Like, what is a Trojan horse? So a Trojan horse is a Greek legend that there's a city. It was conquered by some invaders, and then they come in, and then they occupy the city, and then how they're gonna win this. Because the defense is very fierce. So how they're gonna win this and go through the defense is to pretend to give a gift to celebrate their victory on build a giant horse, but there's actually soldiers hidden inside. The enemy was hidden. So when the horse come in, then they can attack from the horse after they have given this horse into the city. So it's kind of like that, right? You package something that looks harmless, and then put it inside inside your source code, your repo, your GitHub project, and then actually the attack is coming from inside. So that's very scary. There in the paper, I would give you the link at the end, which you can have a look if you're interested. Or you can read this PDF. Actually, this link is the link to the PDF that they published the paper. So it's talk about this three type of the exploitation that they found. Kind of go into three categories. One is early return, so it terminates your function early. So it's supposed to be finished the whole thing, but it terminates early, so it could create some problem. Another thing is commenting out some essential code. For example, I think the example they are used a lot of time is used in the if courses, because then you didn't check, then it always execute, which is something that you don't want. Also, strings have similar concept. You can add additional content in your strings, which makes things work differently. So for example, this is early return, so this is written in Python 3, you can see at the top there. You can see this is completely normal, like the one I show you. Except when I looked at it, I was like, oh, this person is really funny. Like, why they add the semicolon after, at the return in the dot string, right? So, if you don't give a second thought, you may think this is legit, but actually, there's a bidirectional character there, so this is actually how it got rendered. So the return will come outside, and there is the semicolon there, so it kind of end the dot string, and then kind of think that always is enter, almost act like enter, so it will be the next line return. So the thing after the bank checking the account and stuff, all this is not executed. So this is how. This is just an example. It's a bit silly, but it's just by principle how it could work. Also, this is commenting out. So you can see that this also is it's legit. It's actually in C, this one. That's why the comment is using the /star thing. So I don't know. I don't code in C actively anymore. I do learn a little bit when I was in school. I gave it back to the teachers. I can't remember any C code. But so if you write in C, maybe you would be, oh, this is kind of what people do. It may be a little bit funny, but still legit code. But again, putting all these crazy bidirectional characters in there, you can kind of flip a lot of those kind of orders. So kind of those check the if courses is now inside a comment, so it's not actually checking anything, which is a bit no-no for some code. But again, this is a very silly example, but it could really mess up your logic in your program. The last thing, again, I think this is JavaScript. It looks like JavaScript to me. So again, this is looks okay, You just someone put a comment there. It's nothing to worry about. We see comment all the time, as all the good programs would have comments. But again, you can kind of flip all the orders and put the things. That's that's in the comment now is inside the string, and it will mess up your logic again. Once again, your logic got messed up, and your code may do something that you don't want it to do. So, yeah. So this sounds really smart and really need to be well planned. Also, maybe it's not that easy to exploit. But there's also other similar exploitation that also make use of the Unicode characters, but it's not the bidirectional characters, but in a similar kind of way. For example, like invisible character, I think I just showed you that you put, at the beginning of the example when I ask you questions. So I add the invisible character there. So the good in the better cases, you just have an error and it won't execute. In the worst kind of situation is that it will just again hidden there and then mess up your logic. And do something that you don't want it to. Homographs is actually like two characters that look exactly the same, but when the computer render is two different type of characters. So you can use it to kind of overload the function. For example, Python, right? And if you declare two functions with the same name, the second one will get executed. So you may expect that, it's just someone writing a bad code that the second function is overwriting the first one. But if it's homographs, they are two different ones. So maybe they are actually calling the first one without you knowing. So this is C, I believe. So it's kind of work a little bit differently than Python. I think the first one will normally get executed, but because if we now color coded it, then actually in the main section, actually calling the second one directly, but you thought that it's going to be override by the first one. It's not. So Python, there's the researcher who published the paper. They also test out whether these exploitation work in Python. They also will test other languages as well, but I just focus on Python right now. So this is the one that will work in Python. We should watch out for those things. So early return, so we already showed the example. There's also commenting out will work as well on some specific setups there. But it's not limited to this list, right? This is what they have tested that it works, but it may work on the other version as well. Like for example, we have 3.10, 3.11. I haven't tested out, I don't know. So if you want to, you can test it, and if you find something, you can contribute to the CPython and tell them that actually that may have some problem. But the invisible function does not work on Python 3.9, which is a good sign, I think. It's just a list. If you're interested, you can go to that GitHub link to check what the researchers have done on the experiments. So what should we do? Should we be very scared, right? This could be something that we can't trust Python anymore. We can't trust open source anymore. I think no. In general, I think that we should not be too scared about that. It's knowing about it is really good that people be more aware and will be more careful, especially when you are, let's say, browsing the code on the internet. Then you kind of know that there's something that you can't see that may harm you, right? So should we just ban it though? I don't have a good answer to all these questions. I'm not a maintainer for CPython, so I don't know. I'm not proposing anything, but it just sparked some discussion and thought of what you think it should be. So ban the use of bidirectional control characters. But the thing is, we don't have all the fun stuff in Python, right? We can't do all these crazy things with Python. For example, let's say I want to print out or do some web scraping with some language that is written from right to left, then I can't do it if I can't do the bidirectional control characters, because the string that I want to check need to be from right to left or something like that. I don't know, but it will limit the diversity of Python. So I think what I think would be the best for us, being a developer or someone who uses Python, is to have a good text editor to do a good syntax highlighting. For example, the one that I just showed you, the online one, that one actually it took me quite a while to find it, because most of the other similar online text editor, they do highlight hidden characters already. In my IDE, I'm still using Atom. Don't throw X at me. But it will highlight it. So Jupyter Notebook will highlight it. So so a lot of text editors already doing it. For GitHub, I think if you go to the repo and see those exploitation example, GitHub will if they scan the source code and see the bidirectional character, it will give you a, the warning sign, GitHub, the yellow thing, warning sign saying, oh, in this code there's a bidirectional character, you should be careful. So yeah, lots of tools already doing that for you. That's good. Also scan invisible characters, so again, a lot of text editors already do it for you, but if you want to just double, triple sure, you can always find some kind of, Unicode kind of interpreter or something that will show you the invisible characters. I'm just saying here, it's basically just like, and also a good linter, right? I think someone told me that PyLint actually will tell you if there's a hidden Unicode character, it will just tell you. So always use a good linter. So what I'm trying to say is that, like, look your code before running it. When I first learned Python, I have a lot of problems, questions, or stuff that I want to do with Python code, but I don't know how. So I look online, right? We all look on Stack Overflow and stuff. But you look before you copy and paste it and run it. It's general rules of thumb. So we all love Unicode and emojis. We just want to keep it maybe, but we have to be very careful when we copy code from online or something. So yeah, this is the website that I found at the paper, and it's then set up by the researchers. So the credit gives to them. I don't find this out myself. I just read someone's paper. Also, at the end, before you go, I want to tell you about EuroPython, which is in July, which is in Dublin. I think we also have remote as well. If you can't travel, you can also join remotely. So